All right, welcome back to Lagniman Programming. In this video, we're going to take a look at Rust program packages and the whole package layout, and we're going to organize our project around around what's called a workspace. But before I do that, I want to show you a short presentation on that overall layout and how it all works. We'll get into the details of it as we go through it. This is just an overview to show you what things are going to look like. Thanks for watching.
Okay, we're going to talk a little bit about the Rust package layout and how to organize programs around the Rust system, around Cargo, and how it creates and builds projects. The top-level organizational unit of a Rust program is a package. The package contains information about the package and its dependencies and the source code and all the build processes. A package at the top level, it contains a cargo.toml file, a source folder with source files in it. A package must contain at least one crate, and we'll talk about what a crate is. And a package may contain multiple crates, but only one library crate and 0 or more binary crates. And we'll talk about the difference of those two. A package consists of the top level package, and within it at least one crate, and within that crate will be modules with source code. And we'll talk about the module system in a moment. Modules. Rust modules are where we place our code. The top level module is the name of the crate. Modules can contain a public interface. These are public functions that are exposed outside the module. It can also contain private functions and public and private modules. Access to modules. So a submodule may access the private functions of the parent module. A parent module may only access the public functions of the submodules, and this includes private modules. Private modules cannot be accessed outside of the parent module, but the parent module has access to the public functions within the private module. A module layout. So modules are created within a file, or they can be created in separate files, and we'll get into that as we start organizing our project in more detail. The mod keyword creates a module. The code may be placed within the curly braces. It can also be in an external file, and the module just referred to as a module, and we'll get into how that's done as we organize our project. The use statement brings module items, functions, structs, enums, and so forth into scope for the module or function where you're using the use statement. And we'll talk about how that works. You basically create a path to that function. You can bring one single function in a package into scope, or you can bring all of them. There's a variety of patterns for using the use statement. And the pub keyword specifies that a module is public. By default, modules, functions, and everything else, structs, enums, all that are private by default. You have to tell the compiler that it's going to be public using the pub keyword. Crates. So a crate is a unit of organization. There's two types. There's binary crates and library crates. Binary crates have an entry point with a main function that makes an executable. A library function contains library items that you can bring into scope. A single package can have multiple binary crates. File named main.rs produces a binary crate with the name of your package, or other names. You can configure that. You can set up multiple binaries, of course. Other binaries then produce other names, are produced under other names. Additional binary crates can be placed within a bin folder, as we see here. We have a client and a server in the bin folder. This would produce two binary outputs. The crate names are the names of the files, but this can also be changed in the cargo.toml file. Workspaces. Workspace is what we're going to use most likely in our project as we move along. Workspaces are a very powerful tool. They allow you to have multiple multiple packages within a single project. So then each package has its own cargo.toml file, and then the top level workspace has a cargo.toml file that describes the workspace, and we'll be working through that. It can contain multiple packages. Each package resides in its own subdirectory. Each package contains its own cargo.toml file, and the top level workspace also contains the cargo.toml file. And this is the top level workspace cargo.toml file. It tells what members there are, and there are other things that you can do with this. And we'll get into the details of that.
Okay, so now what we're going to do is kind of start from the beginning, and we're going to set up our actual project, and we're going to get it put up on the GitHub, and we're going to set up the first part of a CI/CD pipeline. That's the CI, or the continuous integration. We're going to set up some build actions so that when I push stuff up there, it'll build and create a release, and we'll work through all that. So let's begin here in PowerShell, and I'm just going to go ahead and create our Rust. We're going to call it Rusty Mud. Gotta say cargo new Rusty Mud, and we'll go ahead and make this a binary executable initially, and we'll kind of remove this around. Actually, you know what? I'm going to call this Rusty Mud client, because we're going to move this folder into kind of a no. We're just going to call it Rusty Mud. Yeah, it's the overall project. So here we go. CD Rusty Mud, and now we can open up code. Oops, and of course it came up on the wrong screen. Okay, so now we have our typical, we've already looked at this, our typical source file here. Now, it also created a Git repo for us for Rusty Mud, and we got ourselves a Git ignore even. It's going to ignore target, which is fine. That's all the binary outputs and dependencies and everything are down there in target. So that's really for Rust the only thing we need to worry about ignoring in Git. All right. So, but now what I want to do is organize this into a workspace, and I briefly went over workspaces in the presentation. The way we're going to organize this into a workspace is we're going to start by creating a new folder here that we're going to call it Rusty Mud Client, and that's what this is going to be. We're going to go ahead and drop it into there, move it into there. So now we've got the Rusty Mud client, and we're going to take our top level cargo toml file here and drop it into the Rusty Mud client portion, and go ahead and move that. So there's our Rusty Mud client. We're going to create a new file here called cargo toml, and we're going to make this a workspace. We're going to put this keyword up here, workspace, and then we're going to create members of this workspace, and they are a list. And in quotes, we're going to state Rusty Mud client. So that's the only one that we have at the moment. We'll be able to add more with a comma, and what we're going to do now is just go ahead and put in Rusty Mud server, because we're going to go, we'll just open up a terminal here, and we'll go cargo new Rusty Mud server. This is also going to be a binary file. Now, the interesting thing about this is Cargo is very smart. It sees that we're in a Git repository. So when it created the Rusty Mud server here, it did not create any Git stuff for it. It's already in a Git repository. That's our top level repository here. And now we can do cargo build, and it should build both of those executables. We can rename them if we wanted to, but they're fine like they are. So now what we have is two packages in the same workspace. So we have Rusty Mud Client, Rusty Mud Server. Those are their own little packages with their own cargo TOML file. When we put dependencies in these, it will put them in the overall cargo lock that's up here for whatever dependencies that we've got. And there's our two packages, Rusty Mud and Rusty Mud Server. And oh, I know why. I need to change this. Nope. Client cargo.toml. Yeah, we need to call this Rusty Mud Client. We're kind of changing the name of it. Let's rebuild this. There we go. Let's look at the cargo lock file. So now we have two packages, Rusty Mud Client and Rusty Mud Server, in the same workspace, and we can build them all together, and we can have dependencies on them, and they'll be stored in this overall cargo.lock file. So now we have our basic client and server setup. I'm going to say here, I'm going to say Rusty Mud Server. Rusty Mud, Mud Server. And in this one, we'll go ahead and change this to Rusty Mud Client. Mud Client. Now we can run these. We can go cargo, run, and because we've got two binaries, we have to say bin, and we'll type it out, Rusty Mud Client. It builds it, and there's the client, and now we can do the server. And that works. Okay, now let's go to GitHub and get us set up with a repository. So now I'm going to go over to my repositories. I'm going to create a new repository. I'm going to call it Rusty Mud. And Rusty Mud is available. A multi-user dungeon project in Rust. Make it public. We're not going to initialize anything in here because we're going to push. We need a blank repository so that we can push our project up to it. I'll show you how to do that. We're going to create this, and then I'm going to put some. Once I get it in here, I'm going to put some. Actually, I should go ahead and put those in now, I guess. So we can create a new. We're going to push an existing repository, and I'll go ahead and change this branch to main. We'll copy this. Git branch. -m main. What's wrong with this? Let's try -m main git add dot git commit first commit git push origin main. Aha, there we go. Now we should see our repository. Now I'm going to talk a little bit about, just briefly, about GitHub Actions. So there's this these actions you can create, and there is a default one here for Rust. I have my own set of actions that I created that I'm going to use for this. So let me find where I'm at here. I need to be here. And so these are the workflows that I want. So I'm going to copy, actually, I want all of this, copy this, take it over to our, here, Rusty Mud. Let's get into this, paste, there we go. We got our GitHub issue template and workflows in place. I'm going to double check these workflows and make sure. I don't believe they require any editing. Nope, should be fine. Okay. Now let's go ahead and check this in. I'll bring this over here and we'll go git add dot. Oh, no, don't want to be there. Git add dot. Git commit -m. So we added workflows. Git push origin main. Git push. Let's set our upstream to origin main. Now we should just be able to do git push when we need to. Everything is up to date. Okay, so far so good. Let's go back to GitHub. Check this out. So here's our stuff, and we've got our actions. If we go over here to actions now, it's got a check and lint and a, it's got two, check and lint, check and lint. It has no runs yet. I wonder why they're both called check and lint. That's odd. Let's go back to Visual Studio Code. Is it this one? Nope. Is it this one? No. Must be this one. Oh, yeah. Workflows. Check and lint. Oh, check and lint. You know what? I'm going to change the name of these. I'm going to change this to pull request. And I'm going to change this one to release. Okay. And let's go back over to here. Do this again. Renamed workflows. Git push. And this is going to kick off the workflow. So if we go here to actions, we have pull request and we have release. And I just pushed to, oh, you know why? I need to edit those. I knew there was some edit that I had to do in them, and I'll show you what it is. Let's go back to here. Okay, this on pull request branch main, on release branch main, and we'll quickly commit -m. We're going to change release branch to main. Git push. Should be good. And let's go back. Now we should see our actions running. Change release branch to main. So this is running this. This is the action that I created. So we have a check going on and a test. Rust format and Clippy are running. This stuff is all running in parallel, and I'll explain a little bit about this. GitHub spins these up in little virtual machines and runs these jobs in parallel unless they're required by something, unless like this release packaging requires that these complete successfully. Not too worried about Rust format and Clippy. They're not absolutely required. They usually will pass, but if they are erroring, it's not going to cause a problem. This is just lint. So I don't absolutely require them. I may at some point in time require them. Yeah, it's running these jobs, 2 of 3 jobs completed. It's running them on all platforms. It's running them on at least all the major platforms, Windows, Linux, and Mac OS. And once both of these are completed, it will come over here and run the release packaging. And there, the release packaging is working here. It's doing it for Ubuntu. Oh, maybe I took out Mac OS. I think Mac OS one was erroring for some reason, so I had to take it out. But we'll see here. The release packaging for Windows completes. So now we have our jobs running properly. Now there's slight differences here. When we go back to here to actions. When we go back here to actions, we have one for pull requests and one for releases. I'll explain that, and it'll all be documented. When you put in a pull request, it'll run the tests, but it won't do a release until I approve it. So let's go on and start putting together our server. Okay, so we have our basic project set up and working. There is one more thing I want to add into this. We're just going to create another project here. It's going to be a library. We're going to say cargo new -- library. We're going to call it Rusty Mud Common. And this library will hold stuff that's used commonly between the two, the server and the client. And now it's just telling you that it's not in the workspace yet. Okay, so what we can do is just go here to the cargo toml, and we'll put in Rusty Mud Common, and we'll do a cargo build. Just make sure everything's good. In these library crates, under source, there's a live.rs instead of a main.rs, and it gives us a test that's a nonsense test. It's just running a test routine. We can run tests by going cargo test, and we see that the test passed. Now, if I push this to main, it'll run those scripts again. So let's go ahead and do that. Added Rusty Mud common library. Git push. And let's just run back to the site real quick and see how things are going. And we can see that we're running our script again, the release script, because I pushed it. The only reason the release script is pushing because I pushed a main. I'm going to change that shortly here. We're going to push to a branch that's a little bit different. I'm going to shift my mic here a little bit. So we don't have to wait for this. It can do its thing in the background. Now what I want to do is create a branch. So what I'm going to do is go git checkout -b, and I'm going to call the branch lesson 2 GitHub setup. And so now we're in this branch, and this is the branch that will sit there so we're going to push that branch up to GitHub, and this will have the completed code with our whole GitHub setup in it, and you'll be able to reference that. So in our server, if we have, I kind of have to check the times on these recordings, but basically what we're going to do is just create a simple TCP/IP server in here and just show how we can make connections to it. And that'll be the end of this particular lesson. Okay, so for this particular one, I'm just going to copy paste some code in here into our server, and then I'll go through and explain it. So just make sure that I'm in server main. I am, I'm going to close others. I'm going to paste over this, and I'll go through this. So we're using a number of standard packages. We're using thread. We're using the networking. We need a TCP listener, a stream, and a shutdown, read and write. This is a little function to handle client, and basically it's going to write back whatever you get. It's an echo server, so very, very simple. What happens here is it matches with the stream read, and if the stream read is okay, it does a stream write. Otherwise, it'll print out an error. In the main function here, we're creating a listener on address 00003333. We'll print out that we're listening on that port, and then we'll listen for incoming. And when we get an incoming message, we'll check the stream. If the stream's okay, we've got a new connection. We're going to spawn a thread on that handle client function. And this handle file function will continue to run as long as there's something coming in. And that's it for the server. Now let's create a quick client, and I'll go through and explain it a little bit. And we'll explain these things in more detail. I'm starting kind of, I just want to give an overview first, and we will go into it in more detail. I'm going to open up the client. And very similar, we're bringing in our TCP stream and our read and write. We're going to connect to localhost 3333, which hopefully is, I didn't mess that up. Yeah, 3333. We'll connect, we'll send hello, we'll wait for the reply here. matching the stream, the incoming stream. Read exactly what's there. Reply is okay. Unexpected reply, failed to receive data, errors, and so forth. We'll go over all this stuff. We're going to take this apart piece by piece in the next lesson and start building up our actual server. But this is just kind of to test what's going on. So let's do a build and make sure I didn't mess anything up here. Didn't. So what we can do now is split this screen. We can go cargo run -- bin rusty mud server, and then that'll start the server listing. We're going to allow it access, and then we'll do the same thing here. Cargo run -- bin rusty mud client running, and reply sent hello, await reply. Reply is okay. Terminated. Our little echo server is working correctly. So oops, you know what, I did this whole thing on yeah, we'll lesson 2 GitHub setup. That's fine. We'll put this in there too. Add dot get commit -m setup basic echo server, and do a git push. Origin, and then the branch I want to push. Now this will not kick off a build pushing to this branch. It won't recognize that. So we're good. Just double check the repository here. Oops. I had it open already. And go here, Rusty Mud. We want to go to that branch here. And here's our, oops, source, main. There it is. It's all in place on that branch. So in the next video, we'll start getting into how this works, especially the server side. And we're also going to do some stuff with serialization, deserialization to JSON, so that we can send stuff back and forth. And then eventually we can use this same thing to set up communication channels and send messages and stuff. And we'll get into all that. So that's it for this video. Thanks for watching. I hope you liked it. If you really liked it, hit that like button. If you want to subscribe, it's greatly appreciated. Subscribers help a great deal. And if you want to see when I put out new videos, hit that bell button and set up some notifications, and you'll see when new videos come out. So thanks again for watching, and I'll see you in the next video. Bye now.